Hello. Today is the last lecture on chapter 4, which is Newton's second law, and I will be working on the situation if we have two bodies connected to each other. So just remember from previous lectures, if I have an object and I want to apply Newton's second law, I must do these three steps. The first step, we draw a three-body diagram, okay? The second step, we choose the x-axis along motion and the y-axis perpendicular to it. The third step is to choose whether I will apply summation of fx equal ma or summation of fy equal ma. Usually, I apply summation of fx equal ma if they ask me find the a, find the acceleration. So I must choose summation of fx equal to ma, or if they ask me to find some force which is along x-axis, okay, like friction, for example. Now, when do I use summation of fy equal to 0? Mostly when they ask me to get the normal force. It's always along the y-axis, or any other force which might be along the y-axis, like if I have an inclined plane or a force which is making an angle with the horizontal, then I might choose the y summation of fy equal to 0 in order to find the y component of that force. So if I have a system, before the system, I also want to remind you of the friction force. The friction force is always opposite to motion, and in magnitude, it's mu times n, where this mu can be given, or they will give you everything else and tell you to calculate the mu. Okay, to find n, we use summation of fy equal to 0. So what happens if we have two body problems? If I have, for example, two boxes attached by a rope and I'm pulling them, or if I have two masses connected by a rope and it's over a pulley, similar thing here. If two bodies are connected by a string so that the bodies have a common acceleration, it's possible to use the system approach to calculate the acceleration. How do I use the system approach? I choose the line of motion. So for example, for the first one, the line of motion is this one, okay? And I put all the forces on this line, but I choose it in such a way that it's along, so I choose the x-axis along the line of this motion. And whatever forces are on this line, so summation of F external on this line will be equal to m1 plus m2 times the acceleration. It's the common acceleration. What are the F external? Are all external forces. They are all forces instead except tension. Okay, so I take all forces except tension. So for example, here, if there is no friction, what do I have along this red line? I only have this friction, this force. If there is a friction, then I will also have friction. So if there is a friction, then I will also have a friction here and friction here. So now, if I'm to write this summation of F external, summation of F external equal m1 plus m2a. Okay, so I say, what are the external forces? I have this F, which is given, minus friction 1 minus friction 2. This is equal to m1 plus m2 times acceleration. Notice that the normal and the weight are along the y-axis. So I don't put them here because they are not along the line of motion. The line of motion is the red line. Normal and weight are on the y-axis, so they are not considered. Okay, I don't consider tension because tension is always an internal force. Okay, so this is a very beautiful way to calculate the acceleration, for example, because elsewise I have to work on box 1 alone, then box 2 alone, then use two equations, two unknowns in order to get the acceleration and the tension. This is more succinct. This is more easy to deal with. Let's take this system, for example, you can see that these objects are moving in this way. Let's try to draw it properly. So they are moving in this way, right? So this is here moving. Moving in this way. Okay, so what are the forces along this line? This object has weight and has, let's just change the color. Here there is weight and there is tension, and here there is weight and there is tension. Okay, and the blue line is how they are moving. Okay, so when I come to write the summation of F external equal M1 plus M2A, I will have what's happening here on this line. There is W1, it's on this line, but it's in the opposite direction. So it is minus W1. The tension, I don't consider it. Then here there is tension, I don't consider it. Then plus W2, plus, because it's on the same line as the objects are moving, this is equal M1 plus M2 times A. Okay, instead of W1, I put M1G, instead of W2, I put M2G. Same thing here. I come here and I see, okay, this is M2 is the one which is, they will both move in this direction. So I draw the way they will move. They will move in this direction. First, this one will move in this direction. You can actually just draw it like this. We say this one will move in this direction. This one will move in this direction. So this is my x-axis. Okay, it's in this way, then in this way. Now, what are the forces? Here there is W and N, they are not along this line, and there is tension, which is internal, so I don't care about it. Then I come to this box, there is tension, it is not external force. There is only W2, which is an external force. Now, if I write the equation, I will write W2 is equal M1 plus M2 times acceleration. Okay, so instead of W2, I will put M2G. I have all the M's, then I can get the acceleration. So if that question, if you see a question like this where there are two objects and it's asking for acceleration, my advice to you, use the system approach and get the acceleration. Now, let's solve one more problem from your booklets. Okay, so what do we have here? Two crates of masses MA and MB, 4 kilogram and 2 kilograms. So these are given. MA is 4, MB is 2. They are connected together by a rope. So they are together. So this is a system. And pulled by a force F equal 20 Newton. They're giving me this F equal 20 Newton, which is making an angle 30 with the horizontal. So there is an angle involved. The coefficient of kinetic friction between each block and the horizontal is nu k equals 0.25. This means there is friction. This means there is friction. I have to take it into consideration. Over here, I wrote for you the equation. So for a system approach, summation of F external equal M1 plus M2A. Here they are MA plus MBA. Then summation of Fx equal MA. If on one object, summation of Fy equal to 0 on one object, friction is equal to mu times N. I might use this equation in this problem. So let's start part A. Let's do it here. Draw free body diagram for each of the objects. So in order to draw free body diagram, remember I put my surface. Okay. Then I put the two objects. I put them in such a way that they are tiny spheres. And let's connect them by a tiny line. Okay. And now let's put the forces. So the first object, this one, there is the weight. So let's call it WA. Then there is the normal. So there is NA. Okay. Then there is the tension. I will not call it tension A because it's the same tension from both sides. So there is tension. Then there is friction because there is friction. Okay. So this is the first object. The second object, there is NB, there is weight B perpendicular to the ground. Then there is NB, right? Then there is tension B, okay? Then there is friction B, and plus there is this F force, which is making angle 30 with the horizontal. Let's give them names. This is an A, friction A, W, A, tension A. Then there is tension A. We will just call it tension. We will just call it tension because tension A and tension B are equal. It's the same rho. So this is tension. This is tension. This is friction B and WB and B F. This is F. Okay. So this is the first step. This is the first step. We put all the forces. Then we draw x-axis and y-axis. So if I'm pulling in this way, then both of them will move to the right. So x-axis is to the right. Right? This is x-axis. Y-axis for each object will be upward, perpendicular to the x-axis. So this is x-axis. This is y-axis. This is y-axis. I just have to put the force sign on each force. This is part A. Part B, calculate the components Fx and Fy. Okay, so first I draw them before I attempt to calculate them. This is the force F. This is, sorry. This is the tip of force F, right? So now I go on the x-axis until I reach the tip. Then I go on the y-axis until I reach the tip. This is here Fx. And this is here the Fy. Okay, so Fx, this is here the angle theta. This is here the angle, right? So Fx is adjacent or opposite? It's adjacent of angle x, of angle theta. So Fx equal F cosine angle theta. F is 20 and theta is 30. So Fx is 17.32 Newton. Fy is similarly, but it will be sine angle 30. This is equal 10 Newton. Okay, this is part B. Part C. Part C. Prove that the normal force on MA is given by N1 equal 40 Newton. So they call it N1, N2 instead of NAWA, but it doesn't matter. So prove N1 or NA is equal to 40 Newton. Okay, so here you have to remember, whenever they ask you for the normal force, we apply summation of Fy on mass A is equal to 0. Okay, now what are the forces on the Fy? There is the NA, okay, all of it, because it's all on the y-axis. Friction is on the x-axis, so 0. WA in the opposite y, it's also on the y-axis, but in the opposite direction, so minus WA. Then the tension is on the x-axis, so the y component is 0, so this is equal to 0, which means implies NA or N1, doesn't matter, is equal to WA, which is MAG, which is 4 times 10 equal 40. Okay, then deduce the friction between MA and the horizontal. We just have to remember that the friction is equal to mu times NA, which is equal 0.25 times 40, which is equal 10 mu. Okay, this is part C. Part D. We have to calculate N2 and prove that it's equal to 10. So again, we have to do summation of Fy, this time on MB is equal to 0. Okay, what are the forces on the y-axis for the second object? There is NB. Okay, the friction, the y component of the friction is 0, the y component of the tension is 0, the y component of WB is minus WB, and the y component of vector F is Fy. This is equal to 0, so MB is equal to WB, which is MBG minus Fy. This is equal, MB is 2 times G 20 minus Fy 10, which is equal 10 Newton. Okay, deduce the force of friction. Again, force of friction is equal in mu times NB. This is equal 0.25 times 10, which is equal to 2.5 Newton. Okay, now we need to use the system approach to find the acceleration. Okay, the system approach, the first equation, summation of F external along x-axis, okay, is equal to MA plus MB times acceleration. So this is the equation. Now, what are the forces along the x-axis that are external? There is this FA. So there is, it's FA, but it's in the opposite direction of the x-axis. So minus FA. Tension is an internal force. We don't consider it. Tension is an internal force. We don't consider it. FB, it is on the x-axis. It's in the opposite direction. So we also consider it. Then I have F plus Fx, because it's along the x-axis on the positive direction, is equal to MA, which is 4, plus MB, which is 2. So this is 6A, implies A is equal minus FA, which is minus 40, minus FA, which is minus 10, minus FB, which is minus 2.5, plus Fx, which is 17.32. All of this divided by 6, and I get this to be 0.8 meter per second squared. Okay. Part F down here. We apply Newton's second law on MA. So I only want to apply it on MA to find the tension. So I come on the first object, okay? The tension is along x-axis or along y-axis? It's along the x-axis. So I have to use summation of Fx on MA is equal to mass A times the acceleration. Okay, what are the forces on MA? This is MA. This is here, MA, and this is here, MB. Okay, so what are the forces along the x-axis for MA? There is tension and friction. So there is a plus T minus friction is equal to MA, which is 4 times the acceleration 0.8, right? So first, let's just put it, this is MA times A. Now let's substitute. FA is, we calculated it in part C, it's 10. MA is 4 times the acceleration 0.8 times 0.8, and we get tension equal 13.2 Newton. Okay, so we use the system approach in order to get the acceleration. See how easy it is. And then I apply the Newton's second law on either the first object or the second object to get the tension. I can solve it on MB, and I should get the same answer. But the question is asking to apply it on MA. Let me do it here in blue, in another color. Let's apply it on the second object, just to show you that you can use summation of Fx on MA or summation of Fx on MB, and you should get the same answer. So summation, this is not very clear color. Summation of Fx on MB is equal to MB times the acceleration. Okay, so what are the forces on the x-axis for MB? There is the tension, and it's in the negative direction, so minus T, minus the friction, okay, plus Fx, plus Fx is equal to MB, which is, okay, MB times the acceleration. Let's now put the values. This is a friction B, okay? So friction B from part D, it's 2.5, plus Fx, it's 17.32, is equal to MB is 2 times the acceleration is 0.8. If you do the calculation, you will get tension is equal 17.32 minus 2.5 minus 0.8 times 2, and this will be, this will give you tension equal 13.12, which is almost tension equal 13.2. Okay, so this is the last lecture on Newton's second law. tomorrow we will start with a new chapter, chapter 5. Just to remind you, Friday is exam 2. The material involved is a chapter 3 and chapter 4, that is projectile motion, and chapter 4, which is Newton's second law. Tomorrow we will have the live session where I will solve with you another problem using the system approach. And Thursday during the live session, we will be reviewing, I will be solving the assignment quickly and reviewing and making a review for the exam. Okay, so study well, and tomorrow will be, and we will have a new lecture.